So in the lecture part of this lesson, we saw how to use an array in order to implement a queue. We also saw the abstract data type idea of the queue, and that the first thing that goes into the queue is what comes out of the queue. So if we take a look at our files, we are in lesson 15, and I am in the work directory, and we have 3 different files. So here we've split up the program into 3 different parts. And that's to emphasize the fact that we are using a class, queue, and then we have a third file, the queue test. And if we look at each of these, we can see that the queue.h contains the template for the class. So it contains the private member variables and it contains the public functions. And if we look at the queue.cpp, that's where our function definitions are going to go. And the bulk of our time together then will be spent filling in these values. Finally, we have the queue test. And what the queue test does is it has a main function. So it can be a program. And so it's got a main. And what does it do? Well, we'll fill this in a little bit more. But the queue test file starts by declaring a queue. I called it my queue. And then what does it do? Well, it just exercises a couple of the basic functions for now. It enqueues a 5, enqueues a 7, enqueues a 9, and then enqueues an 11. Then it does a dequeue and it prints it out. So if you think about the metaphor that there's a line at the grocery store and a 5 gets in line, then a 7 gets in line, then a 9 gets in line, then an 11 gets in line. The 5 is at the head of the line. The 5's been waiting there the longest. So if you're going to dequeue, then we should get a 5. And this is an important concept that even if we don't know how the implementation is going to be, we don't have any of these functions filled in yet, we do know what it's supposed to, how it's supposed to act, how it's supposed to behave. So even if we didn't have our functions filled in, we could still write a comprehensive test bench. It just wouldn't work until we get our queue done. But that's the idea of dividing up the labor. So this is what we're going to end up running. And we've got our template. This is our job to be done. And then finally, our main task today is going to be filling in these values. So let's go to the editor, and we'll see the same sort of things. So the queue.h, we've got our constructor, and then we've got 5 things to write. Now the 2 that are critical are the enqueue and the dequeue. Now these are just fancy words for historical purposes. Enqueue means to add, and dequeue means to remove. Now what are our auxiliary helper functions? Well, okay, it might be nice to be able to ask the queue how many elements are in line. And that's when you get size, it returns an integer. Or it might be nice to say who's at the head of the line, but we don't want to change the state. Maybe we're just checking to see who's next in line. And so then that would be return an integer because we are having a queue that contains integers. And finally, we just have an isEmpty, and the isEmpty will return true if there's no elements in the queue. There's nobody in line. Okay, and so this is the template for our class. And when we go to our .cpp file, we'll see that there is an open function definition for each of these. So we go here and we see we got our constructor, we've got our enqueue, our dequeue, our add, and our remove, and then these values here. So if you remember from the lecture portion of this, we're going to have an array, and the first element in line will always be in the 0th spot. And as more numbers get into line, they fill in the higher and higher numbered, higher and higher indices in the array. So what do we need to do? Well, we already have 2 member variables. We've got our data array. We're calling it elements. Sometimes we call it data, but we've got elements. And in order to allow us to have bigger and bigger sizes, we put in a constant here. Up top, then the constant is defined as 100. but it would be very easy to change this to 1,000 or even 1,000,000 if we wanted to have a bigger and bigger size Q. But we've got this variable max size that we can use in order to figure out whether or not the array, to know what the size of the array. All right, so what do we need to do? I mentioned this because when we have our constructor, then our constructor is going to have to do some initialization of the variables. So what do we need to do in our constructor? Well, we've already got an array that has been initialized because we statically initialized the array, but we do have to make sure that size is equal to 0, which means that our first open spot to store something is going to be in the 0 spot, and size forms double duty in that size will also be the number of elements in the array, as well as the spot in which we can put in the next element. So all we have to do is set size equal to 0. Now to enqueue things, enqueuing was pretty easy. So the enqueuing process, all we need to do for that is in our elements, we just need to do elements of size equals the value that was passed in. So elements of size equals j, and then we need to do size plus plus. And that's the basic way to do it. What we do is we store the new element, and then we update size. So by doing this, we put it in the first spot, and then size will get incremented to indicate that we not only have another element, but also that when we put in the next one, then the value is going to go in the next element up. Now dequeue, oh, and of course, I didn't do my error checking here. So we need to do, that, but we're going to concentrate just on the basic operation first. So here, with dequeue, we're going to first have to save the value that's in line. So we're going to say int return val equals elements of 0, because that's the element that's at the head of the line. And we're going to clobber that. So we need to hold it so that later on, the last thing that we're going to do is return this ret val, because we have to return the element that's in the list. So now we do a for loop, and this is going to be akin to at the supermarket when the first person in line gets serviced, everybody takes a step forward. And the first person to be served steps forward, then the next, then the next. And so it kind of snakes on down from the cash register on down, and everybody takes a step forward. So we're going to need a for loop here. We're going to go from 0 up to the size and increment by 1. And what do we need to do here? Well, all we need to do is say that data elements of I is equal to elements of I plus 1. And we should be good. However, now there's one less thing in line, so we have to do a size minus minus. And finally, we have to return the value that was at the head of the list, or ahead of the array. So we've got all of those, and then we've got the error checking. That we will look at next. However, we've typed a bunch of lines of code, and we want to make sure that we don't have any syntax errors here. So even though we don't have everything done, what we want to do is make sure to compile this as we go to make sure that we don't have any errors. So let's switch to MinGW, and now we're in the right folder, lesson 15. I'm going to go back and make sure I saved it. Oh, it was red, so I had a problem there. But when we do this, then we're going to do a G++ q.cpp, and all should be well in the world. Oh, wait a minute. So elements was not declared in the scope. Did I use the wrong values here? So q.h. Elements. Did I spell it wrong? Elements. Look at that. Elements. Elements. Okay. So there, I made an error, but it caught it, and I didn't want to get a ton of errors, so I'm compiling as I go. And compile. And oh, wait a minute. It gave me this thing, and it's hard to read, but it's the WinMain. WinMain. And that indicates, wait a minute, I went through the whole file, all the stuff you gave me, and there wasn't a main. Ah, that's because I'm just compiling a class. So what I need to do is include the -c for compile, meaning compile it, but don't make an executable. And now it compiled just fine. And if I look, I have a q.o, which is the object file. And it's not a standalone run program, but it's a collection of machine code that I can use to link in later. So it did compile, and it did put it in here, but we're not done. So let's continue. So we've got our DQ. We did that. We need to do the error check. Let's go to some of the easy ones. Get size. Well, we've been so nice. We can just return size, and that's good. And then get first. Here we can just return elements of 0, because that's going to be our first element. And then is empty, we can say, now the one way to do this is say if size equals 0, return true, else return false. Should work. But an alternate way to do it is just say return size, and that'll do the same thing. And so now we save that, and boom, look at that. 3 of these just got belted out in quick running order. Let's make sure that it compiles. Okay, no syntax errors. It doesn't guarantee there's no problems with my program. And we've got it. Okay, now the error checks. Now let's think about this. NQ. When can we not NQ? Well, we cannot put anything in if the line is full, if the array is at capacity. So what we need to do is say if size equals max, and what did I called it? Max size here, max size. If size is equal to max size, return false, because we were not able to encode it. And now that's the only thing. There may be some other things, but we wouldn't encounter them if there was a memory allocation error or something. But this is the only normal thing that could happen. Now, DQ. Okay. When can we not DQ? Well, we cannot DQ if there are no elements in the queue. If the queue is empty and you say next, nobody comes up to the front of the line. And so we'd say if size is equal to 0, return, what do I return? I have to return a value. So here I returned false. That made sense. But here I've got to return an int. Now this might be specified in the programming assignment, or it might be specified by documentation. Here we don't know what to return, so we can return -1. There's some other ones. You can return min int if you include ctypes.h, but for now we're just going to say we're going to return a -1. And for both of these, maybe we want to print out an error. If we were going to be testing this and debugging it, we might print out an error message. You could throw an exception. There's lots of things that could happen. But at least we've covered the errors here so that it does something which is at least specified. All right, I'm going to save that and then pray that it compiles. And it does. Okay, now all we've got is the q.o, and what we want to do is we want to run qtest.cpp. So we know that qtest should be just fine, qtest, and I compile that. Oh, whoa. Gives me a bunch of errors. And why? Well, because it calls these functions, but it doesn't know about those functions. Those functions are contained in q.o. So when I compile this, I have to include the q, hard to spell, q.o, and now it compiles. I have an executable, but we don't know if that executable works. We can run it. But before we do, let's go back and check to see what qtest does. And as a reminder, it puts a 5 in line, a 7 in line, a 9 in line, and then an 11 in line. Okay, so what would we expect? Well, it puts everything in, and then we take out the first element in line and we print it out. So hopefully that gives us a 5. And we want to run it. And it says, okay, a 5 comes out. Spectacular. Okay, so let's do a little bit more to test our q. Why don't we take one more element out? Now we'll take 2 more elements out. And so then we should get a 7, and then we should get a 9. We'll compile it again and run it. And so a 5, a 7, and a 9 come out. Okay, so we've got the, why don't we try adding some more things in. I've got my other qtest here. So I'm going to copy in some more lines, and so we need to put some more things in. Actually, yeah, so if we would ever hit a point where I do 2 more DQs, we should get a -1 because the array is empty. So the 5, 7, 9, and 11, the 5s come out, the 7, the 9. We've only got 11 in the queue at this point. So we're going to put in a 15, we're going to put in a 5, we're going to put in a 35, and compile it. And you can see the order in which they go in is the order in which they come out. We'll do one more. Let's do a whole bunch of DQs here, and then that'll be it for this. I'm going to do a whole bunch of DQs. And at some point, the array is going to go empty, and it's going to return that -1 value. And so we should get a bunch of -1s at the end once the, what is going on here? Compile it again and run it, and we get a bunch of -1s because we've run out the queue. Now if we think to ourselves, what if we hadn't caught this error? What if we hadn't caught this error in our q.cpp? So when we dequeue, if this wasn't here, what would have happened? Well, we would have returned the elements of 0, and it would have gone 0 to size, elements, would try to go down, but this would kick out of it. But the problem is that size would have kept on getting decremented. Size would have kept on getting decremented, and it would have gone negative. So we don't want to ever have any negative indices in arrays because those cause segmentation faults. And we've checked it here, and then we have been able to control what value gets returned. And even though -1 is a valid value here, if we're looking at the output and we see a bunch of -1s, that would be an indication. You could put 1111111, any sort of sentinel value that would be noticeable. Like I mentioned, you could also do something like min int. Okay? And your next assignment we will cover in another video.